Hello, my name is Joanna Saishan. I wrote my name on the paper this time. Um, I will be presenting about feedback loops in the non-gravid female reproductive system. The meaning of the word non-gravid is just that the female is not pregnant. Um, there was no fertilization of the egg going on there. So going into a little bit of an overview of the ovarian cycle. The ovarian cycle has three phases in it. The first is the follicular phase, which lasts around 10 to 21 days. It's the period of follicular growth in the ovary. Next, we have ovulation. The ovulation is the release of oocytes from ripened follicles, and these ripened follicles rupture in the luteal phase, and these ruptured follicles become corpus luteum, secreting estrogen and progesterone in preparation for pregnancy. And when the pregnancy does not occur, the corpus luteum ceases to function, and the ovarian cycle begins again at the follicular phase. These three phases of the ovarian cycle, they correspond to three phases in the uterine cycle. First being the menses, occurring at the beginning of that follicular phase. Then there's the proliferative phase, which happens towards the end of the follicular phase. And the secretory phase is the last in the uterine cycle, and it occurs after ovulation. So going into the early follicular phase. Right before this, gonadotropins are increasing. The gonadotropins are luteinizing hormone and follicle-stimulating hormone in the anterior pituitary, stimulated by gonadotropin-releasing hormone in the hypothalamus. So FSH in particular begins to mature groups of, or a group of follicles in the ovary. These follicles contain granulosa cells that secrete AMH, which is responsible for decreasing follicle sensitivity to FSH and preventing additional follicles from developing. The follicles also contain thecal cells, which are influenced by LH, and these synthesize androgens, which can eventually be converted into estrogens. So as the thecal cells are increasing the amount of estrogen in the circulation, the estrogen leads to our first feedback loop. It's a negative feedback on the pituitary gland, decreasing the amounts of LH and FSH, which will prevent additional follicles from developing. At the same time, this estrogen has a positive feedback on gonadotropin or granulosa cells to secrete more estrogen, or just to secrete estrogen, because the luteinizing hormone and follicle stimulating hormone are being decreased. Going into the mid to late follicular phase, granulosa cells are secreting inhibin, estrogen, and progesterone. The estrogen positively feedbacks gonadotropin releasing hormone this time. This leads to a surge in luteinizing hormone, the LH surge, and a slight increase in FSH because it's still being suppressed by inhibin and estrogen in the granulosa cell. With this LH surge, at about 16 to 21 hours after its peak, we have ovulation. Ovulation is when the follicle is secreting prostaglandins and proteolytic enzymes to rupture the follicle wall. The early to mid luteal phase is dominant in progesterone. That's a dominant hormone in this phase. The progesterone, along with the estrogen in circulation, will cause a negative feedback on the hypothalamus and anterior pituitary, shutting down gonadotropin secretion once again. The LH and FSH levels will drop. The late luteal phase and menstruation. So if pregnancy does not occur, if the oocyte, the egg, is not fertilized, then that corpus luteum will spontaneously undergo apoptosis. The corpus luteum was responsible for that estrogen and progesterone production, and after the apoptosis, after it's gone, progesterone and estrogen levels drop. This removes that negative feedback signal on the pituitary and the hypothalamus, which will increase that secretion of LH and FSH that we saw when I mentioned the beginning right before the follicular phase, that gonadotropins increase. This is due to that removal of the negative feedback signal on the pituitary and hypothalamus. Without the presence of progesterone, the corpus luteum will degenerate. The blood vessels will begin to contract in the endometrium, and these blood vessels were feeding those surface cells with nutrients, supplying them with blood, oxygen. So without that, those surface cells die, and they'll eventually slough off, which is the most visible, most well-known part of menstruation, the beginning of menstruation, when the female will have a period, because those cells are sloughing off and leaving the body. So now I have my assignment slide. On the left-hand side, I have the phases in which each of these questions are occurring in. So for the first question, is the early follicular phase, in which thecal cells are under the influence of luteinizing hormone, and they promote blank secretion, and they're promoting estrogen secretion. The thecal cells, they secrete the androgens, which are then converted into the estrogen. The second question, also in the early follicular phase, increased circulatory blank has a negative feedback on LH and FSH, but a positive feedback on blank cells. So with increased estrogen levels in the circulation, there's a negative feedback on LH and FSH, but it positively feedbacks it has a positive feedback on the granulosa cells to increase estrogen levels. And the third one, mid to late follicular phase, estrogen's blank feedback on gonadotropin releasing hormone in this phase leads to blank surge. The positive feedback of estrogen will lead to the LH surge. And in the late luteal phase, we have progesterone and estrogen decreasing here because removing the blank feedback signal in the pituitary and hypothalamus, increasing blank and blank. So as progesterone and estrogen decrease, they are removing the negative feedback signal on the pituitary and hypothalamus, increasing the gonadotropins, LH and FSH. And then after that, I just have my sources slide, and that's all. Thank you for watching.